What's up guys, JS2Cents here. I've done a lot of videos, like 1,500 or 1,600 or something like that. And sometimes it's time to go back and refresh a particular piece of content that I've made. And this is one that I know I've made in the past, but we're gonna do it again today because with a lot of people being new to the PC scene, I've been getting a lot of emails from people that are building their first computers that have finally scored a graphics card and it's been sitting collecting dust for a year, and now that they're finally able to get it fired up, they're starting to ask some very basic questions that I know we've answered before, but things have also changed in this particular industry, specifically regarding fans. So we're gonna talk about the different fan types, what they mean, and where and when you should use certain fan types in your build. Today's video is sponsored by me and these 3 graphics cards we're giving away. You can't see them because they're not actually here right now. Why? Because I want you to click the link down in the description below to see exactly what cards they are. Worldwide, for free, anywhere in the world where giveaways are not prohibited. So if you want to learn all about which cards we're giving away and how to enter and when it ends and all that sort of stuff, then you're gonna have to pause this video, click the link, and go and enter. Don't wait, you'll be sad if you did. You know, like Wayne Gretzky said, the only shot you miss is the one you take and you didn't 100% do. So we're going to start off with a couple of fans I took off the original Skunkworks these are probably about 7 years old at this point. And the reason why I bring these up is when I first started building computers with the channel, there was only a few fan types out there. And what I mean by fan types is you had like your Yatloons, which were $4 or $5 120mm fans that had a very good budget value. They had good static pressure, they had good airflow. But when it came to mainstream companies like Corsair and Cooler Master and all of them, they didn't have obviously as many different types of fans as they do today. And the reason why I have these 2 out here is these 2 fans right here are the exact fans that caused me to have to do this video in the first place way back when my channel was new. These are Corsair fans right here, the SP and the AF fans. And SP, which is this guy right here, standing for static pressure, and AF, standing for airflow, caused a lot of confusion when it came to people specifically regarding fans. Typically, the blade design is what's going to determine what is static pressure and what is airflow. So let's go ahead and start with static pressure. This is the kind of fan you would want to use if you had some sort of resistance to overcome, whether it be fins through a radiator or potentially fins through a heat sink, like a heat sink tower, or you had a lot of air filter, right? If you got a thick air filter or it's got a real fine mesh that has a hard time pulling air through, then you would want static pressure, because the blade design having a very small gap in between the blades means that the air has nowhere to escape to. Air wants to find the path of least resistance. In fact, air is a liquid, which is why it has the same physical characteristics as water. So what happens here is as the blade is turning, the air is being forced to change direction, or at least accelerate. And by doing so, it has to overcome resistances on both sides of the fan, whether it's pulling air through something or pushing air through something. So what you're going to find here is that things that are considered static pressure have a much thicker, not quite so swept blade design. It's a little more flat, which means that you're going to have the air being pushed as strong as it can through the resistance with as little splashback as possible. By splashback, I mean air that can splash off of the frame and go backwards the other direction, or be able to slip between the fan blades, hit the resistance, and bounce back through the other way. So the air comes through and goes, there's resistance, and can actually 180 and come back the other way, because if you look at the gap in the airflow fans, which are the ones on your right, these have a big gap between them. But the reason why the airflow fans have a big gap is that allows it to have more volume of air right there to scoop and push the air. These fans right here, at the time I built Skunkworks, the one in the big Case Labs case, Corsair did not make a static pressure 140mm fan. And I was running 140mm airflow fans on a 560 radiator, which made people really question why I was using airflow fans on a radiator. That's not to say that you cannot use airflow fans on a radiator. You can use airflow fans on a radiator, it's just they're not considered completely optimal because of the fact that the amount of splashback you can have back through here is going to reduce the amount of static pressure, or mmH2O, that you're going to be able to use to overcome the resistance. And depending on the thicker the radiator, the more resistance there's going to be. Now, that was just a trip down memory lane, right? This was pretty simple. Static pressure, airflow. Well, if you fast forward now, you have tons of different brands, almost every single brand on the market, making some sort of fan. Because as fans became more specialized and specific in their nature, different bearing types, they started to get more expensive. These fans at the time were $12 a fan. And I remember everyone losing their mind, myself included, going, 12 bucks. If you've got 10 fans in your system and Skunkworks had 12 or 11, then you would go, that's $130 or $140 worth of fans. Now, a Corsair Maglev RGB fan can cost you $35 per fan. So you can see now how a simpler time back then is almost like welcome today in terms of pricing. But now we've got so many different things to talk about. Let's continue to talk about the blade design because you've got some hybrid designs now, and then we'll talk about bearing type. Because believe it or not, there are different use cases you would want for specific types of bearings. In terms of the size of the fan, these are all 140s right here. This is a 200, this is a 120. The rule of thumb typically, the smaller the fan, the higher the static pressure, because it's a more focused blade. It's a more focused cone of air. So that's why I tend to run 120 millimeter fans on radiators that are 120s over 140s or even 180s where possible. I prefer a bigger radiator where possible, but 120 millimeter fans give you the best static pressure at lower RPMs, which means good noise to cooling ratio. However, 140 millimeter fans, that's been changing because of the increase in RPMs. Typically, the bigger the fan, the slower the RPM, because it takes a lot more torque to turn a bigger blade like this, which puts a lot more stress on the motor, or the motor requires more amps or more watts, which might have exceeded a 3-pin header at the time. But now that motherboards have high amp headers and they can handle 1 amp per header usually, which this particular fan right here is 0.35 amps, so you could run 2 of these fans off a single header without a single problem. This is a 2000 RPM white 140 ER Vardar Evo fan from EK. Now this right here, you might notice, is kind of a hybrid. So if we hold up the airflow fan next to it, you can see where the blade style sort of mimics that airflow design. I'm not saying they mimic Corsair, I'm just saying the science behind the blade types. Radiator fans on cars might look very similar to this. What happens here is you have a very swept blade, which is going to do 2 things. One, it's going to give you a nice sharp scoop of the air, which is going to help increase velocity without having to have the massive density of the fins that you see right here. 2, it's going to make it quieter because instead of having a more flat bladed design like this chopping through the air, you've got this more like a katana slicing through the air, which is nice and clean, which is going to make it less turbulent, which means less noise. But this, because of its gap, its blade count and the blade design means it makes it a great fan for either airflow or static pressure. It's kind of a jack of all trades. It's capable of both. It will be great at both, but it's not specifically built or optimized for either. These were some of the greatest static pressure fans that we've ever used were the Vardar fans, and they even have RGB versions and stuff now. We're not even going to talk about RGB and whatnot because that's an aesthetic thing. That is a subjective choice on whether or not you want the lights and pay the extra for it. Any RGB fan is going to cost more than a non-RGB for obvious reasons. But this allowed for a single fan to be used throughout an entire case, whether it be a radiator, a heatsink, or a chassis, and not have to have different blade shapes and designs all over the place based on what you're using. So this was a good hybrid design. The RPM obviously made up for the fact that it's larger surface area, which means you're going to be able to get a massive amount of airflow or maintain good static pressure at a lower RPM, specifically because of the efficient blade design. The 200 millimeters. This is an interesting one. People ask me all the time, like, should I get a 200 millimeter fan? Cooler Master is kind of the only brand. I think BitPhoenix has a case too that also has a 200 millimeter in the front. Cooler Master's always doubled down on the 200 mil fans. These things are heavy, and by heavy I mean the spinning force it takes to turn a 200 millimeter blade like this versus say a 120. I mean, this takes no effort to turn whatsoever. This takes a massive amount of force to turn. I mean, just look, stopping it with my finger, you can tell it's got some weight behind it. This is only an 800 RPM fan. However, the massive amount of surface area you have with the fins means that this is going to give you a big CFM number, or cubic feet per minute, in terms of air volume of airflow. And with Cooler Master usually putting 2 of these in the front of a case and sometimes 2 at the top of a case means you've just got yourself a nice, slow, high volume of air constantly exchanging through the chassis, which is going to give you an extremely cool environment when it comes to your case. Think of your case as just one big wind tunnel that's always set to low. The problem is every 200 millimeter fan I've ever had from Cooler Master over the years dies within a few years. And the reason for that, again, the amount of torque it takes to turn this blade right here. And if you look at the hub size, they're not that much bigger. They're not running a much bigger motor, if bigger at all, than even say this 140. And then if we take a look at the 120s, you can see they're a much bigger hub, but that's, this takes a lot of effort to turn. So what you'll start to deal with is motor burnout, or even more specifically, sometimes a bearing failure. So the 200 millimeter fans, I mean, look how long that's turning. I barely touch it. There's a lot of weight turning that. But these are gonna give you the best exchange of air in terms of noise to volume. And if you're all about that airflow life, then getting yourself a Cooler Master case that has 4 200 millimeter fans in it is obviously going to give you an insane amount of airflow and cooling in your case. This is just a fan I brought out here that shows how they've sort of evolved the static pressure fan type, where you can see the blades on the old ones, again, are very straight with a slight sweep to them. Whereas the new ones here, you can see they have a lot more sweep towards the end, which gives you that same kind of a slicing through the air, which means that they're gonna give you higher pressure, higher airflow with less noise, but how they have more of a gap between the blades. Corsair's kind of moved over to one blade type now, which again is that hybrid that gives you the best airflow and static pressure capable with a single design without having two different SKUs that it's one specifically designed for the other. Let's talk about bearing types, because these are all different types of bearings. Oh, and this is just a basic NZXT fan that comes with the NZXT cases. These fans are fairly low RPM. This is a rifle bearing actually, but this doesn't have the RPM number on here. This is only 0.18 amps. You could run 8 of these. No, what? I guess you could run 5 of these on a single 1 amp header because they just don't take much power to turn. They're very lightweight. The blade design, instead of being kind of a sweep, it's more of a twisted blade. So you're not gonna get high static pressure, you're gonna get decent airflow. It's not gonna do very good at overcoming any sort of resistance. I wouldn't put these on a radiator, I wouldn't put these on a heatsink, honestly. They're just gonna be good for moving free flow air through a chassis, whether it be an exhaust on the top, the back, or even pulling in air through the front. If it's a mesh type, this probably wouldn't do great with anything that has a lot of turns, whether it be coming through a side vent strip like they find on the H110 or through the bottom. If it's got open airflow in front of it, this will get the job done. But this is probably one of the less desirable fans, I would say, in terms of design that we've ever worked with. Bearing types though. You're gonna see all different types. You're gonna see sleeve bearing, fluid bearing, ball bearing, rifle bearing. There's so many different bearing types. And all that means is, how is the impeller shaft? You all can giggle at the word shaft, right? So you got the blade here, which is mounted to a hub. This hub is floating, and they always move in and out, right? You can see moving in and out a little bit. This has a shaft that goes through it that is, well, coming off of the motor hub, and then the fan hub is mounted to that and usually held in by a C-clip of some sort. But you have to have it floating on there in some way. You can't have friction. So there's different methods at which you're using to lubricate and allow this hub to turn. So fluid is just like it sounds. It's kind of like how the coolant in your water loop on a D5 pump is actually the medium at which the bearing is using, well, on the motor bearing is floating in there with fluid in there. So as fluid's pumped through, it creates kind of a cushion around the ceramic ball bearing and the motor hub itself, or the impeller hub. That's why you never run the pumps dry, because then all of that bearing material is gone. Fluid bearing is just a small amount of mineral oil that is in there to, 1, lubricate, and 2, cause non-contact between the motor shaft and the hub itself. The problem with fluid bearings is, 1, these are not perfectly sealed type systems. Dust can get in there. The dust that mixes with the fluid then turns into like just a mud type of material. And over time, you'll notice if you ever spin your fan and it spins and then goes and just stops like that real fast, instead of freely turning like this, let's say you spin it and it just stops, that means you probably have dust buildup inside the fluid bearing. The nice thing about fluid bearings is you can depending on the manufacturer, usually pop the hub off, clean it with like a Q-tip or whatever, put a little bit more mineral oil in there, pop that sucker back on if the O-ring is good, and then you have a working fan again. The problem is most fans are not considered user serviceable. Fluid bearing is among the cheapest bearing type, which means usually you're not gonna have a clip or anything you can undo to take the fan blade off. You gotta take off the sticker. Usually fluid bearing is the first type to fail. If you've ever had a fan also that spins and then goes, it starts rattling in your case and you smack the case and it stops, that's usually the fact that your fluid is starting to leak out of the bearing. And so what's happening is the fan is becoming off center and it's starting to wobble in there. So you smacking it just sort of like shocks it back into the center and then it'll start doing it again. So fluid bearing. Ball bearing is going to be the longest lasting, least resistance, most expensive bearing type. That's just like any sort of ball bearing that you guys would find. You've got a sleeve that's got ball bearings around the outside. It's perfectly centered. It's always spinning on the ball bearings. They've got their own lubrication. They're a sealed system, non-serviceable. Sleeve bearing. So sleeve bearing is almost like a hybrid between a ball bearing and a fluid bearing, where essentially you have a cylindrical sleeve that protects the hub from the motor shaft. And that's also filled with fluid. So instead of having, rifle bearings, or not rifle bearings, but sleeve bearings on like a big industrial piece of equipment usually has ball bearings in the sleeve itself. Only in the fans, and due to its size, it's using oil to lubricate and center the shaft and keep it from rubbing. Wow, this sounds so sexual. But anyway, I digress. It's a good hybrid between a ball bearing and a fluid bearing, and it's also allows the fans to be oriented in different directions. In fact, we'll talk about fan orientation last. The rifle bearing is very much like a sleeve bearing, only it has rifling inside of the bearing itself. So as it spins, it pulls the fluid up from a reservoir that's sitting at the bottom. So you know how like a screw could pull like fluid up like a hill? Have you ever seen those? Like it's like a corkscrew that pulls water up. So essentially it does that with the fluid, where it pulls it up into the bearing when it's spinning. Rifle bearings are also a sealed system, just like a sleeve bearing. So they're safe to be mounted in different positions. So let's talk about orientation of fans now, because the type of bearing can affect the lifespan of the fan. You're not gonna find like, oh, I mounted my fan upside down, pointing air up, or at the bottom of my case, pulling air up like this. That made my fan die. No, what you're gonna find is different bearings are susceptible to different orientations. Fluid bearing is the one that tends to have an issue with being pointed vertically like this, or horizontally straight up with the hub pointing down. You start to see seepage. You can actually tell if your fluid bearing is leaking. You'll actually see staining around your hub because the oil will start to seep out. And that's when I mentioned like you'll see that you smack the fan and then suddenly it starts to stop rattling. That's an indicator, like I said, that your fluid bearing is starting to die. Ball bearing can be mounted in any orientation whatsoever. That's simply because of the fact that it's perfectly mounted on the ball bearings. The ball bearings are able to deal with the gravity in any orientation. Rifle bearing is extremely happy in this horizontal position versus the side position. And the reason for that is the evenness of which the rifle sleeve is able to pull the fluid up into the hub. Where if you mount it vertically like this, then you're gonna get a little bit of a pooling at the bottom side, and it'll still have no problems with pulling fluid into the bearing, but it's one of those where over time you can start to get seepage at the bottom side of the seal, which then will start to fail that way. Sleeve bearing, pretty much like the rifle bearing, is the same deal where it's gonna be happiest in a more horizontal position. So this would make it safer to use a sleeve, or rifle, or ball bearing on radiators that are mounted horizontally. And any of them will work obviously vertically. It's just vertical fans, if you've ever noticed, are the ones that always fail first. And that's because of gravity, the way that the seals start to wear out over time, and just the fact that oils do like to just seep their way out of seals. And if you have all of it pooling in one part of the hub, it starts to work its way out that way. My ultimate recommendations. These days, fan designs are, I mean, you can see we've got what, 1, 2, 3, 4, 5, 6, 7 different types of fans here. I probably got 15 more in boxes over there. Now, one other fan type I didn't talk about here, which is probably one of the most expensive you can get, and this is a newer technology that Corsair has been really in the forefront of, is the maglev bearing. And essentially, this is using magnets to actually levitate the fan hub off of the motor itself. There's not actually any sort of fluid in here that you have to worry about failing, which is why they have extremely long life. So whereas something like this would be really expensive, you have to start to look at the long-term user reports of how long fans are failing, how many hours, what's the use case, what orientation, because this can go in any orientation with any sort of dusty, dirty environment and still be perfectly fine. Where if you're gonna be changing your fans every couple of years because they continue to, you know, make that sound as they're running, then it might be cheaper to go with a more expensive fan up front. So maglev fans are awesome because they have very little resistance. I mean, you can see I'm barely turning it. It just keeps turning forever because of the fact that it is literally hovering on the hub itself. So what fan is right for you? Honestly, in my opinion, even if we're talking about radiators, I would recommend going with high static pressure fans on radiators and heat sinks. But at the end of the day, I wouldn't rack your brain and wreck your budget in trying to go with a specific fan type for a specific use case. I would go with the one that fits your budget and meets your aesthetic needs. Fans have improved so much over the last 10 years that it really starts to have a diminishing return with spending a stupid amount of extra money over a particular fan type when you consider anything other than its longevity and the environment in which you live in. If you live in a very dusty, dirty environment, fluid bearing is probably not going to be a fan type that you necessarily want to use. They're going to wear out the fastest in your environment, especially if you are not keeping your computer clean or using dust filters. If you vape near your machine, that's also going to create a buildup that can work its way into your fans. Obviously, because the fans are moving that cloud of vapor through the system, and that gets sticky and tacky, and that can wreck any of the fan bearing types. Probably maglev less than the rest, but anything that has any sort of a friction type of bearing that uses fluid or ball bearings or whatever can get gummed up by vape juice and vapor. But I would honestly not worry about what fan type you're using. At the end of the day, the results are diminished the higher that you go. It just becomes the other features, aesthetics, RGB, how nice does the frame look? I mean, all this stuff is designed to make you buy their fan, and a lot of it has extra costs associated, which is not going to be extra performance. So hopefully this video has helped you guys understand a little bit more about PC fans. I know it's a somewhat boring subject, but it's one that a lot of people tend to get hung up on, and you can potentially waste a lot of money. Like I said, by buying $35 fans and loading up your system with them, thinking they were going to give you some sort of an additional advantage to cooling in your system when you found out all you paid for was a pretty frame and some lights in a slightly marginally better bearing type. So there you go, guys. What kind of fans are you running? Put it down in the comments below, how many of them you're running, what the temps look like, and more importantly, how long have they lasted? Do you live in a dusty environment? Do you live in a humid environment? How long have your fans lasted? What type are they, and what did they cost you? And don't forget about our GPU giveaway. Links are down below. It ends on the 31st of this month, and you'll be sad if you missed it. So thanks for watching, guys. We'll see you in the next one.